This iMac is completely dead. No chime, no lights, no power whatsoever. Today, we are going to deep into the logic board and find the tiny component that brought down this system, or at least we're gonna try it. Hello guys, and welcome to another video. Let's see today what is causing this iMac to not start. Now, let's first plug the power cable and see what's going on. Now, keep in mind when plugging the power cable that we have the power supply in here, and this has AC voltage 220, so you have to be very careful what you're touching. Okay, keep in mind this board in here off limits, not touchy. Okay, so we plugged in the power cable and we have only one of the light is lit. You see the first one. Pressing the power button, nothing happened. Dead. You see, it's not coming on. It's not reacting to the power button. Okay, dead. We actually did another video on one of these Macs. I'm gonna post the link as a card in here somewhere on the screen if you want to check it out. On that video, the problem was this Mosfet in here. This is probably the first we're gonna check, and if it's not this Mosfet, it's probably the controller. I'm gonna show you today how to check if the problem is the Mosfet or the driver. But first thing first, before going into the Mosfet and drivers, let's try to see if we have voltage onto the power button. Okay, so we have the power button in here. If we test this with the multimeter, let's see, you see we have 3.4 volts. Okay, so while I'm keeping this like that, I'm pressing the power button, see if it goes to 0. So pressing the power button, you see it's going to 0. So the power button is working fine. Okay, now let's do some digging. We said the problem could be this Mosfet in here, so let's check it. If we put the probe on top of it, you see we have 12.1 volt, so we do have voltage in here. Now let's look at the schematic and see what this Mosfet doing. Okay, so let's go to the schematic and have a look. Okay, so this is our board view. Okay, I rotate it exactly like we have it in here. So we said the Mosfet that could be the problem is this one. Now this Mosfet is U8450 and it's just an N-channel Mosfet. If we look at the configuration in here, we have 1, 2, 3, 4 pins on the outside, and then we have another 4 pins on the inside. All the 4 outside are together. Okay, so the pins on the outside, 1, 2, 7 and 8 are the drain. Then the pins are inside, 6, 5 and 3 are the source, and then we have pin number 4, the gate. Now you see all these voltages are coming from this chip in here, which is marked U8450, Q8450, U8450. Now, so we have the 12 volts that is coming from the system. One goes in here, one goes in here, and one goes in here. So in here we know we do have 12 volts. How does MOSFET work? We said it's an is an N-channel MOSFET. An N-channel MOSFET, in order to open, is like a switch. In order to open and pass the voltage to the source, it needs voltage on the gate. The voltage on the gate has to be larger than the voltage on the drain. Okay, so if in here we have 12 volts or 1 volt or 5 volts, this MOSFET is not going to open, it's not going to pass current. If in here we have 16 volts, then this MOSFET is probably faulty. Okay, it means the chip is providing the right current, the right voltage to the MOSFET, but the MOSFET is not opening for whatever reason. Okay, if we don't have voltage in here, or we have lower voltage than we should have, then the problem is the chip. How can we test this? We do know that we have voltage in here, right, on the input. So this is the input and we checked it. Okay, let's go again. Here's the schematic. Yeah, so we have the drain that is coming the voltage from the outside this chip. Okay, and then we have the gate, which is pin number 7, and then we have the source in here, which are pins 6, 5, and 3, which are coming from pin number 6 of this chip. Okay, well, on the return, this voltage goes in here, so this chip knows that the source is open. Okay, so now what we are going to do is we are going to check, let's see, this gate in here. Now this gate in here, it goes to the chip, right, we said, and it also go to the, let's see, where does it go? It goes to the chip pin number 7. Okay, so it goes to this test point in here, and from this test point in here it goes to pin number 7. Okay, now we are going to check on this test point in here and see the voltage. Let's go back to our board. So we said this is the chip, this is the MOSFET, and this little one here is the chip. Okay, so we know that we do have 12 volts, right? Okay, so what happened to my ground? My ground is gone. Let's see. We know that we have 12 volts in here, right? You see 12 volts, right? But let's see if we have voltage on the gate. Okay, so for that I'm going to put the microscope and let's have a look. Okay, so we are here, right? Now this is our MOSFET. Let me put the, okay, so this is our MOSFET and we know it's 12 volts. These 4 pins in here, 1, 2, 3, 4, and the outside is the drain. The source and the gate are outside. But if you look in here, we have a test point. Okay, in here we have a test point. This test point is for the gate. Now, what voltage we have on this test point? Let me have a look. So on this test point, we have actually 0.8 volts. You see, 0.8 volts. This MOSFET is not going to open. What I'm going to do to try to test it? Well, first of all, let's unplug the power cable. Okay. And I'm going to come with the power supply here. You have the power supply on the screen. Okay. So we put the power supply 14 volts, right? That is over the limit, over the voltage on the drain. Okay, so we are 14 volts on the power supply. On this test point in here, that goes directly to the gate. Now the power cable is connected. If you see, we only have one light. Let me turn a bit the light off in here. You see only one light. Okay, there's only one light. If I press the power button, it's not working. Now let me connect the power supply, the 14 volts on the gate. Okay, so connecting the 14 volts on the gate, check out. Now have a look. You see all the three LEDs. All the three LEDs are on, and the laptop is working. Now turn it off, and it turns off. If I turn it back on, it turns on every single time, because we are now opening the Mosfet. Turning it off, it turns off. So let me see if I can put it under the microscope so you can see what I'm doing in here. Okay, so I'm holding on this test point, right? You see the LED. Okay, now check it out. Pressing the power button. Wait, let me see. You can't see, right? Let me turn off the microscope light. Okay, so now if I press the power button now, we have still 14 volts on the, you see, and you hear the sound. Pressing the power button again, all the LED off, only the first one, which indicates 12 volts, is present on the motherboard. Pressing the power button again, and it works fine. Now let me remove this 12 volts from here. You see this test point in here, this is the gate. So if you don't have in here at least 12 volts, this MOSFET is not going to open, and you're not going to have voltage on the source. Okay, this is the MOSFET and this is the driver. Now you see we are not pushing any more 14 volts on this MOSFET. If I press now the power button, the iMac is again dead. So what's the solution for this? We know the MOSFET is fine because it's opening when we have gate voltage, and we know that we don't have gate voltage. Step number one would be replacing this chip. Okay, you replace this chip, you will start working. Another thing you can actually do is remove the MOSFET and bridge the source to the drain. Okay, this would also fix the problem because you're bridging it manually. So in this video we successfully brought back this iMac to life by identifying the faulty component, which is this micro little chip in here. Now we tested the power supply is working fine. We tested the button is working fine. We tested that we have input voltage on the MOSFET drain, and we've seen that we missing the voltage on the gate, which is provided by this chip. By injecting 14 volts to simulate this chip is working fine, we managed to get this iMac to start. So you're replacing this chip in this case, the iMac should start fine. If you learned something today about component level repair, if you find this video useful and interesting, please hit that like button. And for more fixes like this one, please make sure you subscribe. Thank you, and I'll see you in the next video.